हाँ बच्चों, yesterday we were talking about the transportation problem. In continuation with that one, yesterday we have calculated the IBFS. What was IBFS? That was known as the initial basic feasible solution. We calculate initial basic feasible solution. For calculating the IBFS, we have used 5 rules. I am going to mention it here. That was northwest corner rule or method. Then the second one was the known as row minima method. Third one was known as the column minima method. Fourth one was known as the least cost method. Fifth one was known as the Vogel's approximation method. Vogel's approximation method. I am taking the same problem. What we discussed yesterday, we are going to take the same problem. Look at the problem. This was the problem. This was 3 by 4 matrix, which we solved yesterday by making use of all these 4 methods. Out of that, the row minima was giving us the row minima was giving us the minimum value. The value was 99. The value was 99. I am going to write down again that one here. Look at here. And here, this we have already calculated. I am taking the same one here. We calculate the IBFS by making use of the row minima method. And this was the values which we got by making use of the row minima method. I am not going to repeat it. This we have discussed yesterday. So, we will move further. Basically, the total cost was, this we have already calculated, 3 into 6 plus 1 into 1 plus 3 into 2 plus 4 into 7 plus 4 into 5 plus 2 into 13. The value was 18 plus 1 plus 6 plus 28 plus 20 plus 26. Look at here, 19, 8 plus 18 plus 1, 19 plus 34 plus 46. If you count it, 2, 5, this is 99, this is 99. Whether this value is optimal or not, for that we are going to perform the optimality test. Whether this, because this is the minimum value, out of all the 5, the Vogel approximation method, this gave us the minimum value. And yesterday we have explained why VAM is preferred over the other methods. The reason being, here there are 2 costs associated with the VAM. So that is why VAM, there is a probability of getting the optimum result in case of the VAM. So whether this 99 is the optimal or 1, for that we are going to perform the optimality test. Let us focus on the optimality test now. For whether this solution is optimal, this 99, or whether we can reduce it further. For that we perform the optimal. There are 2 types of tests. One is called stepping stone method. Stepping stone method. This is also known as hit and trial method. Stepping stone method. The second one is known as modified distribution method. Modified distribution method. This is also known as MODI method, MODI. MODI method. We are making use, or this is also known as UV method. In some of the books you will find this is also known as UV method. UV method or MODI method, this is the same method, or modified distribution. This stepping stone method, this is also known as hit and trial method. We are going to discuss in today class only this modify method. modified distribution method or UV method. So let us focus on this one. For performing this MODI method, there are two conditions. Two conditions has to be met. What are the two conditions before applying this one? Look at that one. What are the two conditions? The first condition is all allocation must be in independent position. All allocation. These are the allocations. The 6, 1, 2, 7, 5, 13. All allocations must be in independent position. Independent position. This is the first condition before the applying of the MODI method. If any of the condition does not met, we are not going to apply this. The second condition is your actual number of allocation. Actual number of allocation must be equals to required number of allocation. Required number of allocation. And what is the formula for calculating the required number? You can count down the actual 1, 2, 3, 4, 5, 6. And for calculating the required, there is a formula m plus n minus 1. What is m? M is the number of rows. M is the number of rows. What is n? N is the number of columns. N is the number of columns. Minus 1. Number of rows here are 1, 2, 3. Number of rows are 3. Number of columns are 4. 1, 2, 3, 4. Minus 1. Basically 3 plus 4 is equal to 7 minus 1, 6. So actually is also 6. Required is also 6. If you count it here, this is the actual 1, 2, 3, 4, 5, 6. So once it is equal, you can proceed further. Now we are going to perform the MODI method, that is the modified distribution method or the UV method. Let us focus on that one. Now I am going to solve it. What is the step number 1? The step number 1 says, look at here. What is the step number 1? Make a cost matrix for allocated cell. I can mention it here. Cost matrix for allocated cell. This is the step number 1. Allocated cell. Cost matrix for allocated cell. What is the cost matrix? This is the allocation. This is the cost matrix 3, 1, 3, 4, again 4, 2. This is the cost matrix for allocated cell. Go to the step number 2. Go to the step number 2. I rub it here. Go to the step number 2. What is the step number 2? The step number 2 says that make a UIVJ matrix for allocated cells. Make a UIVJ matrix for allocated cells. Now, what is here? I do it here. I mention it UI. This is basically U1, U2, U3, U4. On this side, VJ. Here it is VJ. This is V1, V2, V3. Rest of the things, please write it down as it is. This is 4 and 2. Clear? So 3, 1, 3, 4. And moreover, what was the first condition? All allocation must be done. If you look at any, it is not going to. If I choose this one, this is fourth corner is open. If I choose this one, again, this corner is open. Clear? So this is called all allocation must be done. So I have made UI VJ matrix for allocated cell. UI plus VJ, UI VJ matrix for allocated cell. For allocated cell. Now another step. Look at here. How to make it? If you look at here, how many questions you will get? You will get 1, 2, 3, 4, 5, 6. I can mention few of the here. What is there? This is V1 plus U2 is equal to 3. Similarly, V1 plus U4 is equal to 1. Similarly, V2 plus U2 is equal to 3. V2 plus U3 is equal to 4. Similarly, V3 plus U1 is equal to 4. V3 plus U4 is equal to 2. Now, what to do? make a matrix. Now this is another matrix. Look at here. Another matrix again, ui vj matrix for non-allocated cell. ui plus vj matrix for non-allocated cell. And how to calculate that one? Look at here. Here we have not calculated. This is another step. Here if you look at here, if I put you can put anywhere out of this V1, V2, V3, U1, U2, U3, any 0. If I put it 0 here, let us assume I put it 0 here. This is 0 plus 4 is 4. 0 plus 4 is 4. This is the matrix actually. I have taken U1 to be 0. What is V3 is equal to 4. Once we get any value 4, this is 4. This is 4. I can put it like this one. This is 4. This is 0. I can put it like this one. Once I know this, this is 4, this is 2, this is minus 2. Clear? If it is minus 2, here it is 1, this is 3. Clear? If it is 3 here, here it is 3, this is 0. This is 0 here, this is 3. 0 plus 3 is 3. Because if you substitute here, you can take any of the 1 to be 0, then later on, then 3 plus 1 is equal to 4. So we are able to get all the. Now, what happened in the second step? I put it hyphen, this is the for non-allocated cell. These are the allocated cell. Where I put a hyphen, this is the allocated cell. Here it is 3, 0 plus 3, 3 plus 0 is 3. Next 3 plus 1 is equal to 4. This is 3 plus 0 is 3. This is 3 minus 2. This is 1. Here it is 4. 4 plus 0 is 4. There 4 plus 1 is 5. Any doubt? Anybody having any doubt? Now go to the, this is UIGJ matrix for non-allocated cell. We go to the another step. This is called cell evaluation matrix. This decides whether the solution is optimal or not. This cell evaluation, it will decide. Now calculate cell evaluation matrix. Calculate cell evaluation matrix. Now how to calculate? Put a hyphen as it is, which was there in a previous table. Now this 3 has to be subtracted from the original value. 9 minus 3. 9 minus 3, I can mention it here, 9 minus 3. This is 6. Clear? This is 5, this is 4. 5 minus 4 is equal to 1, is equal to 1. Now, here it is 3, 7 minus 3. 7 minus 3, it is equals to 4. Then 6 minus 1, 6 minus 1 is equal to 5. Another thing, 8 minus 4. 8 minus 4 is equal to 4. Then 7 minus 5. 7 minus 5 is equal to 2. If you look at here, all costs, whatever the value we got in a cell evaluation matrix are positive or 0. Here all are positive. This is 6 here, here it is 1, here it is 4, here it is 5, here it is 4, here it is, all are positive. If we are getting this value to be positive, means the solution obtained is the optimal one. What was the solution? This was the solution, the 99. So this is the best solution which we got. We cannot reduce from, this is the optimal solution. So that's it, the optimal test we have discussed with the modified distribution method, and we will solve the other problem. We already got 137, 11, these values, these are not the optimal one. Once we perform the optimality test on this one, in that case we will get the same results 99 after doing so many iterations. The iteration part is left because here in this case we don't require any iteration, because in a very first step we are able to get the optimality results. Thank you very much. We will perform the optimality test in the next class. Thank you.